So just when we thought Pythagorean Theorem couldn't get any better, we now get to do it in 3D. This is just awesome stuff. And so what we're going to do is we're still going to apply Pythagorean Theorem like always. And we all know Pythagorean Theorem. Let's all write it down. Ready? Go! A squared plus B squared equals C squared. And C, of course, is a hypotenuse. Okay? So we look at this picture here, and we're going to have to find the missing sides that they want. Well, sometimes it's a little confusing to look at this picture, so I wanted to show you what we're actually looking at. It is a figure. Actually, this is the tray of my indoor grill, but it's going to act as a rectangular prism for now. And what we're looking at, if you look at this picture here, is we would be looking at a figure that sits about like this. And we're going to find it on this one first. You can look at it however, but it's the diagonal that goes inside. Inside is what we're looking at. And we're looking at a shape more like this. And it kind of angles off, and you can see it like that. Okay? And if we were looking at this one and doing this one, we would see that what's happening is that we have this side right here. I'm going to color that in green. But then the other side we need goes right here. Because in order to find this diagonal, I have to know what that side is. And all they gave me were my edges. So they're going to give me the edges right here and right here. Okay, so turn that upside down for a second. I'm going to get that edge, and I'm going to be given that edge. I have to find this, which right now is a hypotenuse. Okay, so I'd have to find that edge. Then what happens is if I turn it like this, you can kind of see it. I know this side. They gave me the height. I just found this side under here. I'm going to now find this one using Pythagorean Theorem. So now I have a leg and a leg. And this right in here, that diagonal on the inside, that becomes the hypotenuse. Okay? So I just thought it might be helpful if you could kind of see what we're looking at as far as where it's going. Okay? So, going back to this side over here, we know this side is 4, this side is 3. We want to find this side in here first, so then we can find this side. So we have to concentrate on the base right down here. We're going to use Pythagorean Theorem. Okay? Our hypotenuse is x. We know that one leg is 3, one leg is 4, and we don't know the hypotenuse, which is x. So we plug that in, we get 9 plus 16 is equal to x squared. Combine those, we get 25 is equal to x squared. What do we do now? That's right, we take the square root of both sides, and we get 5 is equal to x. That is this right here. This is 5. So now we're looking at this triangle here. We're looking at this triangle right here. That's that inside diagonal, okay? So, if you want to, sometimes it's easier to pull it out and see what we're looking at. So now we have that this side that we just found, that is 5. This height right here is 12, and we're finding this diagonal. That's what we don't know, and they called it y, so we'll just be consistent. Okay, so all we're doing is we're pulling it apart and coming up with those triangles. So now we're going to plug this into Pythagorean Theorem. 5 squared plus 12 squared is equal to y squared. So 25 plus 144 is equal to y squared. 25 plus 144 is 169. I'm going to pause for a second, make sure that you're with me on all of those. Okay, and now what do we do to both sides? Right, we take the square root. Oh, and look at 169. We should recognize that. That's a perfect square. 13 is equal to y. Okay, side note. These are what are called Pythagorean triples. See how it's a 3, 4, 5 triangle and a 5, 12, 13? Those are Pythagorean triples. Yeah, it's all kinds of cool stuff. You'll get to learn later on as we go. Okay, of course, now they want to put it into words, but they were nice enough to give us a picture, too. Renee plays softball for her college team. She went home to visit her parents for the weekend and took her favorite bat to practice at the batting cages. After returning to college, she realized that she left her bat at her parents' house. The largest rectangular box that Renee's father can find has a base that is 28 inches by 18 inches. Use the Pythagorean theorem to determine if Renee's 34-inch bat will lie inside the diagonal from the bottom of the box to the top of the box. The box is 8 inches tall. I was getting too excited about doing the problem, I couldn't even read it. So what they're telling us is here is our box, 28. So here's one side, here's another side, and then here is our third side. Okay? We have this bat that has to lay in here. So here is our bat right in here. We have to see, will it fit? And her bat is 34 inches long. So we're going to see. So what we have to do is, in order to find that diagonal right there, that bat, we're going to have to find this segment right here. So this is a right angle inside there. So we're going to take a leg and find the hypotenuse. So 18 squared plus 24 squared is equal to x squared. Pull out your calculators. I don't know 18 squared. I'm sure you don't either. So we're going to take 18 squared. Oh, well, everybody do this. Go. Let's find x. I'll pause it. Everybody come back in a few seconds and we'll talk about. So hopefully you got an answer now. And what did you find out that x was equal to? 30, right? So this in here is 30. So now we're looking at this triangle, this one in here. It's like it's sitting up inside the box. So we have the side, which is 8. We have what we just found, which is 30. We're trying to find out the length of this bat. We want to find out if that bat will actually fit inside. So this is, what we're using there is actually the converse of Pythagorean theorem. We're going to see if this is true. We did this in one of the example problems, one of the homework problems. So we're going to take 8 squared plus 30 squared, because those are our legs, and we're going to find out, is this true? Is this equal? Question mark. Okay? So what we're going to do is we have to square each of these and see if this is a true statement. Go. Use your calculator. So as you were doing this, you hopefully squared all of those, and we came up with 64 plus 900. It doesn't equal 1156, but would it fit inside? If it were equal to it, it would fit inside. So this is smaller than that, so therefore, yes, the bat will fit. The reason the bat will fit is because, oh, wait, I said that wrong. The bat, when squared, is 1156. This box will not contain it, so no, it will not fit. Okay, so you guys already figured out my mistake, I'm sure. I realized that, wait a second, I think that bat's supposed to fit. So, did you find my mistake? It's right here. That was supposed to be a 28, because that says 28, and for some reason I wrote a 24. So let's check it. Let's do it one more time. So I apologize if I threw you off too much. So we have 28 squared, which is 784. Add that to 324. We get 1008. I take the square root of that, and I get, oops, I'll just put it in, 1108. And we get 33.286, blah, blah, blah. Now, the problem we run into is that when we go to plug it in, okay, we have an approximation. Okay, so I'm just going to tell you right now, the better thing to do is to actually leave it as square root of 11, the square root of 1108. Okay, so let me show you what I'm talking about. If I have a piece of scratch paper, I can get some more room in here. So wrong, this is wrong because I had this wrong. So now I'm going to take this side, which is 33.3, approximately 33.286, blah, blah, blah. So what I'm saying is, if I want to be more exact, I'm going to actually take this number, this x squared. See how I'm going to have to go square it? So I'm going to take the 8 squared. I'm going to take the 8 and square it. And then what I'm going to do is take the square root of 1108, and I'm going to square that. I'm going to get a more accurate answer if I do that. So if I don't have a perfect square there, I can leave it as a square root and square it. I can also approximate it, and it would probably work. And I want to see if that's going to be big enough to fit in a 34-inch bat. Okay, so I have 64 plus, and also it makes it really easy to square. The square root of 108 squared is just 1108. When I add those two together, I can't even add today. I get 1172. Is that going to be equal when I take the square root of that? Because I'm supposed to square this one. Is that going to be equal to 34 squared? Okay, so I'm going to take... So, is that going to be big enough? Well, if I take the square root of 1172, that gives me square root 1172. I get 34.2. Is that big enough to fit a 34-inch bat in there? It sure is. So if this comes out to be 34.2, that means this diagonal right here, this thick green line, is 34.2 blah, 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 blah. So therefore, this is big enough to fit that bat in there. So yes, I was right. The bat does fit. I just did the math wrong. Okay, the bat does fit. And anyway, okay, moving on. My mistake. Sorry about that. If that is a struggle for you, come in and see me during a review time or set up a time. Okay, now this next part is pretty nice, because all we're going to do is we're going to find the distance between the points on our coordinate plane. And guess what we're going to use? You're right, Pythagorean Theorem. So we get to plot points. So we're going to plot 1, 3. So 1, 3, and 4, 7. Okay? And we're going to find out the distance between these. We want to find that distance. So what we're going to do is we're going to say, well, if I make it into a right triangle, I can use Pythagorean Theorem to find it. What's the distance here? 1, 2, 3. What is the distance here? 1, 2, 3, 4. And I'm going to use Pythagorean Theorem to find out what this distance is here. So this is my distance that I plotted. I have to draw in a right triangle. So I'm going to take 3 squared plus 4 squared. And of course, I want the hypotenuse. So I have c squared. This gives me 9 plus 16. It gives me 25. If I take the square root of both sides, I get 5 is equal to c. Okay? Questions? You can't actually ask them anyway, but you know where to find me. Okay, so let's look at number 2. We're going to plot the points. -3 and 3, and 2 and -9. Okay, so we want to find that distance right here. Okay, we're going to find that distance right there between these 2 points. So you have to make the right triangle. Now here's the cool thing. You can make your right triangle be right here, or you can make your right triangle be right here. It does not matter. Okay, it does not matter. But that is going to be the hypotenuse. Drawing a right triangle. So here to here, I could use that one, or I could have used this one up here. It does not matter. It's still going to work it out. I drew this one darker, so I'm going to use that one. So what is the length here? 1, 2, 3, 4, 5. The length here is 1, 12. That one's 12. So we're going to plug it into Pythagorean Theorem. Write down Pythagorean Theorem. Go. Plug those in. Find C. Go. So you can see that when you plug it all in, you get it down to the square root of 169 is equal to c squared. 169 we know is a perfect square. That's right, 13. So we get c is equal to 13. Okay? That is what it is equal to. Now this says round to the tens place if necessary. It wasn't necessary on these two because we came up with exact answers. You can imagine that we're going to hit one down here that it does. Okay? You can see it's pretty basic what we're doing. So I'm just going to pick one that we're going to do. Let's see. Let's do this one, and then we'll pick one of these. Okay, so let's plot our points. -3, -3. And we have 3, 3. We want this distance right here. You might not all have a cool ruler like I do, my grandpa rules. But you can just use a straight edge. Obviously, I got that one free. So now you're going to draw in your right triangle. Make it into a right triangle, and that's the hypotenuse. It doesn't matter which way you do it, just whatever hits you. Draw in a right triangle. Now, we're going to find the distance of these two just by counting. That's 6. And that's 6. Okay? Plug that into Pythagorean Theorem, go. So you're going to take the 6's and square them, add them together, you get 72. You're going to take the square root of both sides, and we're going to get C is equal to the square root of 72. And we get 8.48528, blah, 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 blah. So I get 8.485, blah, blah, blah. Round it to the nearest tenth. 5 or above, give it a shove. So it's going to be 8.5. Now that becomes an approximate. You don't have to put the approximate symbols, but I just want to get you used to the idea that anytime you have a non-perfect square, it's going to be an approximation. Good. Okay, let's do one more. Which one? Which one? 5 or 6? I wish you were here. It really doesn't matter which one. Let's do 6. Okay, so we're going to plug in the points 0, 2. There's that point. -5, 1, 2, and 9. So we're going to find the length right here of this segment using Pythagorean Theorem. Okay? So if you're ever given a line and you need to find the length of it, make it into a right triangle. So if it's on a grid, you can easily do that. Or if not, make it onto a grid. Okay? Go. Try this one. So we know that our two legs are 5 and 7. Okay, go. Use Pythagorean Theorem and find the hypotenuse. So if you plug it all in, 5 squared plus 7 squared, and again, I said that in the wrong order, but it doesn't matter because they're both legs. You get the square root of 74. I got 8.602, blah, 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 blah. I want to round it to the nearest tenth. 4 below, let it go. So it becomes 8.6. Okay? Questions? Come and see me. Let's look at what the homework is. Okay, so your homework is just the next page in your packet. This looks like this should have been the notes. This should have been the notes. I think I printed that wrong somehow. This is definitely the notes, but that's okay. We can figure this out. So, on this side, do you really need to do 9 to figure out if you got it or not? How about if we do 4? 1, 2, 3, 4, 5, or 5. You want to do the evens again? Let's do the evens. So do 2, 4, 6, and 8. And on the back, what I'm going to have you do one problem on this grid, and then use your notes grids for the other, and let's see which two we're going to pick. Hold on. So I just looked at the answer key for this, and it looks like all of these can fit in this square, in this grid. So I'm not going to make you do all of them. I think you can do it in probably 3 or 4. So pick 3 or 4 off of here that you are going to do. Plot them on here. See if you get it right. If you need more, use these right over here. That's fine. We didn't use those grids for the notes. So you're going to do the evens on this side. You're going to do at least 4 of these. I'll let you choose which 4. Check your answers. Because you are reviewing for the test, and we review starting tomorrow, and test is next week. So you need to make sure that you practice these enough to get them. I want to show you on this, though. Let's do one. I'm going to look at number 3, because it gives you this information, what you've got to draw in. If you've got to realize that what they are asking you to find, oh, I can't draw on this. Hold on a second. Okay, what they're asking you to find, what you need to realize is that you need to draw this in. From here down to here is what you're going to eventually find. Find the rectangle, find the length of a diagonal. So that's what you need to find. What you need to realize is that you have to draw in this other stuff. On the problems that we were doing, it was already in there. So you have to find this segment right here. It's part of this right triangle down here. Then you have to use it to find this diagonal. Okay? So I'll help you out with one of yours. We're doing the evens. I'll draw in number 6. So number 6, you need to find this segment first. And then ultimately what you're going to find is this segment right here that goes from here down to there. You see that? So what we're asking you to find is this diagonal. You have to go through and find that diagonal on the bottom rectangle and this diagonal of the entire box. Great. Hope that helps. Thank you very much. See you soon.